Law of sines and law of cosines. This is just an extension of chapter 7.7. So the trig ratios you have seen so far in this chapter can be used to find angle and side measurements in right triangles. You can use law of sines to find angle and side measures in any triangle. Okay, so it doesn't have to be a right triangle. Law of sines. If triangle ABC had side lengths of AB and C, as shown, then the sine of A divided by A equals sine of B divided by B equals sine of C divided by C. Okay, generally speaking, out of these three fractions, you only use two at a time. So you use two of these fractions at a time. The capital letters represent the angle measurements at those vertices, and the lowercase letters are the side lengths. Let's take a look. So notice on the triangle, if you go across from angle A, you have the side length at lowercase a. If you go across from angle B, you have the side length of lowercase b. And if you go across from angle C, you have the side length lowercase c. Example 1, use the information in the diagram to determine how much closer you live to the music store than your friend does. So here's your home and here's the music store. So we need to find this side length here. We need to find B. And then here's your friend's home and the music store. So we need to find this side length here. That's side length A. Now we can set up all three fractions. All right. So we said the law of sines, sine of angle A divided by A equals sine of angle B divided by B equals sine of angle C divided by C. All right, you can only solve for one variable at a time. And you can see at point C, we have the angle, and across from point C, we have the side as well. So this side length is going to be C. All right, since we have both the angle and the side, we're definitely going to use the one with C. So sine of C is going to be the sine of 34. And side length C right here is going to be 1.5. So lowercase c is 1.5. All right, and let's take care of the one with B. We can see angle B is 65. So the sine of B is going to be sine of 65 degrees. Okay, and this should be a lowercase b. I made a little mistake. Okay, and side length b we do not have. All right, so now we have our fractions. We have one variable, which is good. Of course, we're going to cross multiply. So b times the sine of 34 degrees is going to equal sine of 65 times 1.5. All right, and solving for b, the opposite of times sine of 34 is divided by sine of 34. And that's in degrees. You do the same thing to both sides. It cancels here. Okay, and we need to do this on the calculator. Okay, make sure degrees is in boldface. And we're going to do the sine of 65, close parentheses, times 1.5. Okay, sine of 65 times 1.5, hit equals, and then take that answer divided by sine of 34, close parentheses, hit equals. All right, I'll use one decimal. Notice the second decimal is a 3. It's less than 5, so we're going to round it down to 2.4. So this whole thing, rounded off, works out to approximately 2.4. So that's going to be for B. Now let's do the same thing with sine of A. All right, I'll do it in a different color. Actually, I'll do it in red. Okay, sine of angle A. We can see angle A is right here. That's 81. So it's going to be the sine of 81 in degrees divided by lowercase a. And lowercase a, we don't know. That's the side length. Okay, and now we're going to cross multiply again. All right, so I can just erase this for now, and we're going to cross multiply these two. I'll do it in a different color. Okay, top times bottom, we have sine of 81 times 1.5. Sine of 81 degrees times 1.5. And that's going to equal A times the sine of 34. All right, let me make more room. A times the sine of 34. Okay, solving for A, the opposite of times sine of 34 is divided by sine of 34. Okay, we do that to both sides. And of course, the 34 is in degrees. On the right, sine 34 over sine 34 cancels. We need to do this on the calculator. Okay, we have the sine of 81, close parentheses, times 1.5, divided by sine of 34, close parentheses. You can do it all in one step, or you can hit equals after the first two. Okay, so hit equals. Look at the second decimal. If it's less than 5, we're going to round it down to 2.6. So 2.6 is the approximation for A. All right, so we said A was 2.6 and B was 2.4, and they wanted us to find the difference. Okay, so simple at this point. It's just going to be 2.6 minus 2.4, and that equals 0.2. And the units were in miles. Okay, so you are 0.2 miles closer than your friend's house. Okay, so you're 0.2 miles closer than your friend. And they got the same answer. All right, law of cosines. If triangle ABC has sides of length lowercase a, b, and c, then all of these work. Okay? And just like before, I'm going to comment on this in a minute, but just like before, you want to remember that the capital letters represent the angle measurements at that point or vertex, and the lowercase letters represent the sides across from those angles. So across from angle A is lowercase a, across from angle B is lowercase b, across from angle C is lowercase c. Now, really, all of these formulas are the same. So I like, if I had to memorize it, I like to just use this one here because it is closest to the Pythagorean theorem. All right. The point is, you have to go by the angle measurement that you actually have. You see here, in order to use this one, you need the angle measurement at point A. And in order to use this one, you need the angle measurement at point B. And this one, you need the angle measurement at point C. Okay, C does not have to be the longest side like Pythagorean theorem. C just has to be the side across from the angle that you're given. All right? So the truth is, it really doesn't matter which angle is A, B, or C, as long as you use the respective letter across from the respective angle. Okay, that's why I say really this formula is really the only one you need to know, because you're only using, as you can see from the cosine, you're only using one angle at a time. So let's say you were given this angle right here. You can certainly make this point angle C, and then you would have to make this side length C. And then, of course, you'd have to change this to an A and this side length to an A. Okay? So like I said, these are all the same formula. They just mixed up the letters. You can just memorize one formula if you needed to, and then change the letters and sides on the triangle itself. Example 2 in triangle ABC at the right. A is 11, B is 17, C is 9. Find the measure of angle C. All right. So we're given 3 side lengths, and we're looking to find the measure of angle C. All right, so this one happens to use angle C in the first place, but this right here is the formula for the law of the cosines. So you do the Pythagorean theorem minus 2ab cosine of C. All right, so let's write that out. All right, Pythagorean theorem. C squared equals a squared plus b squared. Pythagorean theorem, and then minus 2ab times cosine of C. All right. So in this case, we don't have to change any letters because cosine of C, we're looking for angle C. So that works out perfectly. So C is 19. C squared is going to be 19 squared. A squared is going to be 11 squared. And B squared is going to be 17 squared. Minus 2 times A, which is 11. Times B, which is 17, times cosine of C, which we don't have. Now, you can certainly get numbers for these if you want, but I like to do the work before going to the calculator. We're trying to isolate cosine of C. So I'm going to subtract 11 squared and also 17 squared. These are both positive. So I'm going to do the same thing to both sides. Okay, 11 squared minus 11 squared is gone. 17 squared gone. I'll do this part on the calculator right now. Okay, I get negative 49. Bring down the equal sign. And we have negative 2 times 11 times 17 cosine of C. Okay, again, you can get a number for this if you want, but I'm just going to divide both sides by that mess right there. Negative 2 times 11 times 17. All right, if you want to get the number in advance, you certainly can. And this is all multiplied. This is all multiplied. It cancels. All right, I'll do this on the calculator. Negative 49 divided by, parentheses, negative 2 times 11 times 17. Hit equals. All right, I get a big decimal. So I'm going to round it off for now, but I actually kept the decimal in the calculator because I want the answer to be as accurate as possible. Now, finally, since we're solving for C, the way to get rid of cosine, which we've done before, is to apply the inverse cosine to both sides. Okay? So I'm going to apply the inverse cosine to both sides. And over here, cosine and inverse cosine cancel. So I'm going to do this on the calculator. I'm actually going to do this part first, and then I'll take the inverse cosine of that answer. Okay, negative 49 divided by, parentheses, negative 2 times 11 times 17. Close parentheses. So the negative 49 is divided by that whole thing. Hit equals. Okay. Before we round it off, 0.131. I'm not sure if this is going to help at all, but so we have our answer here. I'm going to do inverse cosine, okay, or arc cosine. And on this calculator, if you click ANS, they give you the last answer. Close parentheses and hit equals. All right, looking at the second decimal, if it's more than 5 or more, you round up. This is going to be 82.5. So basically, from this equation, angle C is going to be 82.5. And that's in degrees. Now, the diagram isn't always correct, but I like to look and see if the angle looks like what we got. 82.5, well, I can see that because this is a little bit less than 90. Okay, they actually just did one decimal, so they just got 82. I mean, they did no decimals, nearest whole number.